So our investigation into elastic collisions involved using a simulation, but what challenges would we have to deal with in a real world, in a real physical experiment? Well, we'd find that the moving trolleys would slow down before impact due to friction. There'd be friction between the wheel base and the cart, and whatever surface the cart was moving along. And there'd also be some air resistance as well. So after the cart is given a push, it's going to slow down before it gets to the other cart and collides with it. And what we're interested in is the velocity of the cart at collision. So there's going to be a bit of an error there, and you'd have to be able to try and measure the velocity as close to the collision as possible. Now, to overcome this problem of friction, we could use an air track, and the air track will blow air through little holes all along the track, and it will make a cart float along it. It's quite a cool thing to use. And what other challenges would we have to deal with? Well, one of the main ones would be that we'd have to have some way of measuring the velocities of each cart and the velocity of the combined cart as well. Now, to do this, we could use light gates and data loggers, where the computer measures and records the velocities automatically, or else we'd have to do it manually, and this would be quite difficult, and we'd have to set out particular distances and times with rulers and stop clocks, and so this would be an added challenge, and there'd be more columns in our tables, be more data to record, and then to manipulate that data to find the momenta of the carts before and after the collisions. And so there's be more steps, and it would be a little trickier to do. So using the simulation is actually quite useful, but we could do it with a physical apparatus if we had some sophisticated equipment to do that.